Okay. So today we're looking at coefficient of correlation.
Mm,
Yeah. So the interesting part about this topic is that the theory is not so much, but
okay.
it's a practice that's really intense. And the other issue that you need to understand is this: is most of the ideas that you're going to come across and how to treat these computations, you've already come across them in the computation of the mean and the median and the standard deviation. So this is just
Mm,
from a different perspective, all right? The
okay.
ideas are just the same. You don't really have to stress a lot and worry. And the other point is this is one of the most fundamental topics because the moment we're done now, if you go through a question paper, you're going to guarantee finding a question that you need to practice with. So that's why it's very, very important to go through this question. So let's begin with the theory, right? So our introduction says, what is coefficient of correlation? Coefficient of
Mm,
correlation is just a relationship between two variables, right? If
yes.
a woman and a man they've got a relationship, or we can say that they've got a correlation. If Zika and you, the accountant, you've got a relationship which is a professional relationship, we can say it's a correlation. Your employer and your employee, right?
Mm,
It's a correlation. So basically, what we're trying to come at when we're going through a coefficient of correlation is we're just trying to find the relationship between two variables, right? And now this relationship takes different forms. There's certain relationships that are direct, right?
mm,
Right? There are certain relationships that are direct. So now, before I explain this, let me go further into the exam. When you be writing, this is what you need to respond whenever the examiner asks you about coefficient of correlation. So when you perform this computation, right, the
mm,
coefficient of correlation that you're going to find, it's supposed to be between 0 and 1, right? Right.
mm,
So there's 0 and 1, and then also -1 and what? And 0. Right? So it just runs from -1 until 1. So numbers in between this range, those are going to be the figures that you're going to relate the correlation to. So the most important thing, right, that you need to understand is this: there's a direct relationship. What's a direct relationship? The direct relationship here is when variable x increases, variable y also increases, right? You haven't.
mm.
I don't know if you've done economics, the supply and demand.
No.
Okay, not yet. Okay, I could have used this analogy to explain it had you done economics, but let me also touch on that. So, the principle of demand or the law of demand simply states that as the price reduces, the demand increases. So it makes sense when the price of an item reduces, there's high demand, right?
Mm,
Yeah. Then from uh, the supplier's perspective, there's also what we call the law of supply, right? So the law of supply is from a supplier's perspective. When the price goes up, the supplier is going to
mm,
produce more so that he can make more money. So now, what I'm trying to
mm,
explain here is for the direct relationship, when variable x increases, uh, variable y also increases, right? I
not
know here
reduces.
it's, yeah, and here
Mm,
it reduces. I think it's just a typo. It's supposed to be increases. So it's a direct relationship. When variable x increases, variable y also increases. So it's similar to
mm,
the law of supply, right? So whenever the price goes up, the supply of that item what goes up as well. So it's like
mm,
it's an upward curve. A curve is going upward.
mm,
That's a direct relationship. So when you calculate the coefficient of correlation, which is signified by R, right? So when R is
mm.
a positive number, it simply means the relationship between those two variables is what? The relationship is positive. But
Okay.
the inverse, right? Inverse relationship, it simply means when the price of an item goes up, the demand goes down. When the price reduces, the demand goes up. So now it simply
Mm-hmm.
means when variable X increases, variable Y reduces. And when you're
Mm-hmm.
calculating the coefficient of correlation and then you find the coefficient of correlation as a negative figure, it simply means that relationship is inverse, right?
Mm-hmm.
Then there's also what we call a strong relationship. So a strong relationship, right? When the figures are closer to
Yes.
zero, right? You find 0.9, you find negative, so you find 0.9, right? You find negative 0.1, right? Those
Mm-hmm.
figures are closer to zero. So it simply means the relationship there is strong. Then there's also what we call a weak correlation. So the farther away a digit is from zero, right? Or
Mm-hmm.
rather, the farther away the digit is from one, right? Then that's a
Mm-hmm.
weak correlation.
Okay.
You understand? So, for instance,
Yes.
if we have a coefficient of correlation of 0.3, then it simply means that relationship is weak, right?
Mm-hmm.
But if we have a coefficient of correlation of 0.9, then that relationship is what? Strong. But now that
Wrong.
number is positive. So it simply means you have to tell the examiner saying, okay, this relationship between these two variables is, if it's a positive number, is direct. And then if it is closer to 1, you have to say the relationship is what? Is strong.
Strong.
Yes. But if the digit that you find is a negative, right? Then it simply means you have to tell the examiner the relationship between these two variables is what? Is inverse. It's indirect, right?
Okay.
And then if
Mm-hmm.
it's far away from one, right? The farther away it is from one, right?
Mm-hmm. Yes.
Then it simply means that relationship has got a weak
Is weak.
correlation. Yes.
Mm-hmm.
So now, positive correlation, you've seen the
Yes.
relationship, yes, it goes upwards. So now, if we're talking of the strong relationship, a strong correlation, these points, these data points that you're seeing, they're supposed to be closer to the line. It simply means
Those
the
those black
relationship.
dots.
Yes, the black dots are supposed to be closer to the line. It simply
Mm-hmm.
means the relationship is what? Is strong. Then
Is
negative,
strong.
it's downward sloping, right? For the
Mm-hmm.
virtue that it's downward sloping, right? Then this relationship is what? It's inverse, right?
Mm-hmm.
And then when it's a vertical or it's a horizontal curve, it simply means there's no relationship, there's no correlation. It simply means the correlation is equal to what? Is equal to zero. So this is just for
Mm-hmm.
illustrations purposes. But the key points that you need to understand is whenever you compute, right, these figures,
Yes.
is the relationship strong? Is the relationship weak? Are the figures closer to one? Are the figures far away from one?
Mm-hmm.
You know, that's what the relationship is. Then what's the formula for a coefficient of correlation? My advice is you have to memorize this, right? So that it's easier for you to compute in the exam. Of course, the formulas are given, but if you memorize, it saves you a lot of time. So R is a coefficient of correlation. You've got N. N is a frequency of all the numbers in a data set, right? And then summation of X, Y. You have to create the tables. Summation of X, right? Summation of Y over the square root of n summation of x squared minus the summation of x squared, right? So x squared, this x squared here is what you bring here, and then you square it, right?
Mm-hmm.
And then the same thing repeats with the y variable n summation of y squared minus the summation of y. What you have here is what you bring here, and then you square it. This is the formula that
Mm-hmm.
we're going to be working with when we're calculating the coefficient of correlation. Then there's also
Okay.
what we call the coefficient of determination. So there's not a lot that you need to know here, but the key that you need to understand is the coefficient of determination is basically the coefficient of correlation squared. So whatever coefficient of correlation you find it, and then you square it, right? You find coefficient of correlation of 0.3, and then you square that, and you are going to find the coefficient of what? Determination. So what does it measure? The coefficient of determination simply measures, right, the ability of a model to predict or explain an outcome in a linear regression. So this is mathematical knowledge, but the layman's explanation is, what's the extent to which variable x is affected by what's the extent to which variable y is affected by variable x? So variable x is the independent, and then you've got variable y, which is the dependent, right? So variable y depends on variable x. So now when you're calculating the coefficient of determination, you're basically trying to assess how much of the changes in variable y are being affected by the changes in what? Variable x. Right? So if variable x changes, how, like, what's the impact on what? On variable y.
Why?
So even when you're explaining to the exam, you have to say, if you find a let's say a coefficient of determination of maybe 0.6, you can just say, we can explain by saying the changes in variable y, right, are being explained by the changes in variable x. So 60% of the changes in variable x are being affected by the changes in variable what? Variable, yeah. So the 60% of the changes in variable y are being affected by the variable x. So the key point that you need to understand is variable x is the independent. So like the way we have these figures here, so this is x. You remember this mathematics, eh? This is x, this is y. So this is the independent variable, this is the dependent variable. So yes, when you find the coefficient of determination, you need to explain saying most of the changes in variable y are being affected by changes in variable x. Or you can say 60% of the changes in variable y are being affected by changes in variable what? Variable x. So that's just a little bit of theory that you need to know. But otherwise, you know, when push comes to shove, this is the calculation that's most important. And also being able to explain the figures that you find. So there's also what we call the coefficient of, this is supposed to be coefficient of determination, variation rather. So let me edit that real quick. So I just copied the slides. So this is the, what is this?
It's gone.
It's gone?
Yes.
Oh, okay. I'm coming. Let me share it. Yeah, so I don't know if you have any questions so far.
No questions.
So this topic is one of the most important, if not the most important, because when you get a question paper, immediately you are supposed to you know, find, you'll be able to compute and calculate the answers.
Okay.
Yeah. So let me just share my screen again. Just a minute, eh? Can you see it?
Not yet.
Not yet. What's happening? What's happening? Okay, I think now you should be able to see it. You can see it, huh?
Yes, I'm able. Yes.
Yeah. So I was saying the coefficient of variation, it measures the dispersion of the data points in data series around the mean. So all this, it doesn't matter. What's most important is what? the formula here. So in the exam, you'll be required to calculate the coefficient of variation, right? This coefficient of variation is basically found by calculating the standard deviation of, so if you've got variable x and variable y, and then you are told to find the coefficient of variation for both of them, like independently, right? So you have to find the standard deviation for variable what? Variable x, and then you also find the mean for variable what? The same variable x, and then you divide the two. So standard deviation divided by the mean gives us the coefficient of variation. So the way we're calculating the standard deviation, if this is ungrouped data, the same way we're supposed to calculate. And then the same way we calculate the mean for ungrouped data, and then you just divide the two, and you're going to get what's called the coefficient of what? Variation. So with that said, our lesson has been concluded, but we need to calculate, rather we need to go through a question.
Yes.
Let's just go through a simple question. We're just going to make up some figures. Then we go through the question. So let me share my Excel. Okay, so just confirm for me if you can see my Excel.
Yes, I can see it.
Okay, so I'm just going to make up figures here. So we're going to have x here, and then we're going to have y. It's just going to aid with explaining the concept. So so we've got y. So we've got numbers 1, 2, 3, 4, 5, 6. What am I doing? I want them to be like this. So one, just say answer plus. So equal to this plus 2. Right? Then I'm just going to go up to, just going to have at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just going to have 10 of them so that we don't so now the other figure here we can just say 20, huh? Okay, now let's say 10. So let's say 10. Where's my Excel going? Okay, we said 10, right? And then we say equal to this plus maybe we just say 5. Then we do that. Right? So in the exam, this is the way the questions are going to come. You're going to have x variable, you're going to have y variable, right? And then it's up to you to memorize the formula, and you need to be able to know what to do and where, right? So we've got these and these figures here. So the first thing that you need to calculate is x squared, right? We've got x squared, right? Next, you find y squared.
Y squared.
Then next, you find xy. Then next, right? What's the other thing on our formula here? Let me just confirm. Yeah, I think that's all. That's all. So we've got x, y, x squared, y squared, and what? Xy, right?
Yes. And also xy is there? Xy, yes.
Hello?
Okay, yes.
We're together, right?
Yes.
Okay, so let me just finish up my table here. Okay, so what's x squared? So we just square this one, huh? So we just say so this is equal to that to the power 2, right? Right, and then we do the same for all of them, right? And
Mm-hmm.
then what's y squared? I'll just get in this. I'll just get in that to the power 2,
Mm-hmm.
right? And then what do? You bring them down here. Then xy, what's xy? I don't know if you can help me with this.
xy, so we multiply 1 by 10, which
Yeah, exactly that. 1 by 10, right? And then that repeats over. So next, we need to find the total, right?
mm-hmm.
Because we're supposed to find the sum for these figures. So the total for this is equal to sum. So sum. Okay, why isn't it bringing? Okay, sum of that equal to, and then you repeat the same for all of them, right? You've seen the numbers that we have here.
Yes.
And then let's find the coefficient of what? Correlation, right?
Yes. So the formula is n open.
Yeah.
N open brackets, the total, the summation of xy.
Mm. So now the
Close
other
bracket.
issue. Okay, sorry, just a minute. So the other issue that we haven't dealt with is what's in. We haven't sorted out what n is. So n,
Okay.
from your own judgment, what do you think n can be?
The total the total number of I think n is the total terms of x and y.
Yeah. So yeah. So n is just 1, 2, 3, 4, 5,
Yes.
6, 7, 8, 9. Right? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, you got it correct. So 9 is just the total terms. So all the terms for x and y, which is 9, right? Yeah. So for x, you've got 9 variables. For y, you've got what? 9 variables. So n is just
So
basically
are there
9.
instances where the variables are different for x and y?
I've never come across such a question. But
Okay.
if such a case were to come, so the way it is right here, so
Mm-hmm.
obviously there's some form of relationship, like there's some form
Yes.
of growth, right? So
Mm-hmm.
obviously you can use that to calculate. You just establish what's the difference, what's the trend, right? From this to this, from this to this, or from this to this, and then you just use that to find the next variable. That's if you're not given y, but x you're supposed to be given no matter what, because you can't have y without x, because x is the independent and y is the dependent.
Dependent. Okay.
Yeah. So firstly, um, we need n, right? So let's calculate the numerator. So the numerator is n. So just help me with the formula n, which is 9, right?
Yes, which is 9
9 multiplied
plus
by
multiplied by the summation
you
of
know, x, right?
no, the summation of xy.
The summation of xy, okay. Then next,
Minus
uh-huh,
total x
okay, x, uh-huh,
multiplied by total y.
okay.
Summation of total y, yes. Then we
So
close.
right, so that's the answer that we're finding.
Then we need to do the square root.
Okay, so now for this square root, you need to add them separately. So first of all, obviously when you're writing, you can you put the square root. So you
Mhm.
begin with the section for x. So what's the section for x?
Yes. The section for x, we have n
Okay.
n n multiplied by the total summation of x squared.
Okay, multiplied by the total summation of x squared. Okay, and then what else?
Minus the total summation minus.
Hello? Hello?
It's squared.
I didn't get that. You're not audible.
I hope I got.
Yeah. So the n which is 9, right? Why am I putting 7 here? Hello? 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 Hello?
Yes, I can get you.
Yeah, I couldn't get you. Yeah, you're saying?
So I'm saying what did we end? So down there we've dealt with n
Yeah.
multiplied by the total summation of x squared
Yes.
minus the total summation of x, but it must be squared.
Squared. Okay.
Yes.
Okay. So total summation of x, right? So this is this, huh? Right? This, and then we square it, huh?
Yes.
To the power 2. Right? Then next, minus what?
Then that's done.
Yeah. Then for the y,
For y, it is n
yeah,
multiplied by the summation of y squared
summation of y squared, which is this,
minus the summation of y,
y
but it must be squared.
squared,
Mm.
yeah. So when we perform the arithmetics for everything, right? What are we finding a negative here?
So we must then those two must multiply, isn't it? The
Yeah,
two
they
for
must
y.
multiply, not okay. Yeah, they must multiply. Okay,
Yes.
okay, okay. Let me do it. Let's find them separately, as I initially stated.
Mm. Yes.
Okay. So the x component is this, huh?
The
This is the x component, and then this is the
yes, the y.
y component. A y component. So I think this negative. Let me just remove that. Okay, it gives us that. So next,
Yes.
we need to multiply these, right? So we need to multiply this
Yes,
x
multiply those.
component. You multiply the x component by the y component, right? And then you
Yes.
find the square root, right?
The square it's the yes, the square root, yes, after
Yes, the square root
multiplying
of
them.
everything, right?
Mm.
So we have this multiplied by
Multiplied by
this,
yes.
right?
Yes.
Giving us this.
Yes. Then the square root.
Yes. Then now we find the square root.
The square root, yes.
Square root. Find the square root, huh?
Mm.
Oh, luckily today I've got my calculator close by. Yeah, so the square root of 2916, then 4 zeros,
Zero,
right?
zero.
One,
Yes.
two, three, 4. It's giving me 5,400.
Okay. The
Right?
same one that is on top. Yes.
Yeah,
5,400.
5,400. Right? And
Okay.
then you find this
Divide
component.
by,
Yeah,
yes, divide by that square root,
yeah.
which is
So
1.
yes. So which is 1, eh?
Mm.
Right? So R, I'll just say R, right, is equal to 1. So now when you find this, what does this mean?
It means is it a strong,
Yeah, it's a strong relationship. There's a
strong
strong relationship
relationship?
between these two variables. But in the
Mm.
exam, you won't always find one. You know, you find 0.1, 0.3, 0.6, 0.8, 0. All these are, but you have to recognize, and the closer the figure is to 1, the stronger the
Mm.
relationship.
But the number cannot exceed 1, isn't it?
Yes, it's just supposed to be within 1. So it's either -1 and 1. So
Okay.
this range between -1 and 1, that's where the coefficient of correlation can,
Okay.
yeah. So
So
the,
now, what other question can they ask since we found one in terms of explanations?
so you have to explain what's the relationship between these two. So 1, we have got +1. So it simply means there's a direct
Mm.
relationship between the two variables. As 1
Mm.
increases, the other one what? Also increases. So there's a
Increases. Mm.
direct relationship. Number 2, this relationship is strong. Why? Because we've got an absolute figure of what? 1.
Mm.
Right? And then when
Okay.
you're finding the coefficient of determination, what do you say? You have to say, oh, 100% of the variables in y, they are being affected by x, or 100% of the variables in y can be explained by changes in variable x.
X. Okay.
Yeah. So with that said, our lesson has come to an end. So we just made up these figures, but still we've we are within the range of -1 and 1. So this is what coefficient of correlation is. There's not much to do, and this is what it is.
And that's why the topic ends for this
Yeah,
one.
yeah, it ends. But there's also another section or component of coefficient of correlation. It's called least squares line. So it borrows the
Okay.
similar ideas with that of the coefficient of correlation, but it, you're trying to find a trend, right?
Okay.
You're
But
trying to find figures of y, right?
okay.
So we've got figures of y here. If they're so far apart, like the relationship is very weak, you're trying to find a line, right,
Okay.
that we can draw between these figures that are so far apart, such that that line
Mm.
can be as accurate as possible, that it can touch as many points as possible, and that's what's called the least squares line. That's what we're going to look at next week. But with that
But
said, our lesson has come to an end. Yeah.
so do we also have something to do with group data and group data for this?
For this, no. What we've learned, that's it. That's coefficient of correlation. So if I
Okay.
guarantee you now, if after this lesson you pick up a question paper, you're going to find a question relating to this. So just
Okay. Let me just.
pick any random paper, and then you see it.
Okay. I'll open one before I even knock off.
Yeah. So with that said, our lesson has come to an end. So this week is done. Next week we're going to look at the other topics. So of course in
Mm.
financial accounting we need to look at because I want to touch on bank reconciliation.
Mm.
Yeah, bank reconciliation. Yeah, then next week of course we're going to look at least squares line for statistics, and then for law it's obviously employment law.
The one I'm having challenges with.
Oh, you've already studied it.
No. I'm saying I'm still having a bit of challenges with law, but
Uh-huh.
I'm sure I'll get there. Yes,
Oh, I know. Don't worry. You
yes,
you will. Yeah. With
yes,
that said,
yes.
we can conclude our session today.
All right.